Evening, everyone. So, welcome to our ASP Astronomical Society's live panel discussion session for the Perseverance Rover landing. We know that the Perseverance Rover, the Perseverance mission, is actually a mass exploration mission by NASA, which was launched last year in 30th of July 2020. So, yesterday, I think yesterday or 2 days ago, the landing actually happens in March at this Jezero crater on Mars. So today we'll have a discussion about this landing. And first, let me have a simple self-introduction. I'm Lai from Astronomical Society of Penang. I'm one of the committee member of Astronomical Society of Penang. And together with us tonight, we have Dr. Chong Hon Yu, our president of Astronomical Society of Penang. He's an amateur astronomer, have a lot of experience in explaining in outreach event, including space exploration and astronomy. So say hi to Dr. Chong. Dr. Chong.
Hello, bye everyone. Okay, Okay.
And then we have David To Junzian, also a member of Astronomical Society of Penang. He's currently a student in Nanjing University of Aeronautics and Astronautics, short form NUAA, first year degree student. So hi Junzian.
Hi.
And also we have Marcus, our youngest member, which has a lot of experience in astronomy and space exploration outreach event. He's 13 years old this year, Form 1. So hi Marcus.
Hi.
Marcus, you can do it, okay?
Yeah.
Right.
Okay.
So without further wasting of time, so let's start this session today. So maybe Dr. Chong can give a simple introduction on the background of this Perseverance mission.
Very good evening, everyone. Okay, we are all of us are in Penang. All right. Most of us are on Penang Island. One of them is Marcus Singh is in Batuan. All right. So I'll just present now. Okay. Pick one. Then I'll pass to the next person. Okay. So now, can you see my PowerPoint?
Yeah.
Yes.
Okay.
Before Dr. Chong starts, I'd like to add on something. If our audience have any questions, you're welcome to ask us through the comment section in the YouTube channel or also below on the comment section below the Facebook page. So all questions are welcome. So we hope we can answer your questions or we can discuss about more information. We'll try our best to give the best answer. So Dr. Chong, thank you.
Thank you, Lai. So good evening again. Now is 21st of February, Saturday, about 8:30 p.m. It's already 2.5 days that Perseverance has landed on Mars. So when he landed on, let me see, in the Jezero crater, as mentioned by Lai, at about 5 a.m. Malaysian time on Friday morning. Although they say 18 February is American time. Remember, Malaysian time is always 12 hours ahead of American time if you are in New York or in Florida. So landed. So now 2.5 days already. So a lot of things has happened. But then a bit of information. So when it happened, this is the first picture from Mars. So this is the first picture from the underbelly of the rover. There's a hazard camera, so you can see the rocks. And now I say, why so blur? You can know there's a kind of a lens, a cover to protect the camera lens still on. So the lens cover is a bit distorted, give the image. So now I think they dropped the lens cover. So this is the first picture, black and white, with the lens cover still on. This is looking in the southeast direction, all right? And then this is on the left, the same picture. On the right is the front part. This on the left is the front part of the rover. The right is the back part of the rover. And see like this. And then the scientist straight away saw. It landed here in the. Remember, this is the landing ellipse. It's about 8 kilometers long, 7 kilometers wide. And this green dot is where it landed here. But the Jezero crater is very big. Remember, Jezero crater is about 45 kilometers in diameter. That means you can put the whole of Penang Island inside Jezero crater. You can put the whole city of Kuala Lumpur inside Jezero crater. And maybe this area here could be where I'm staying lah, Jelutong lah, Jelutong Island Place, or this could be the place of Kepong, right? So it's very small only. So it landed here. More information. And there's these two places. The important thing is here. This is the river delta that they want to know. Another one here it landed. All right. Here it landed, and here it landed. This is the delta they want to see. And this, what is this? Now they go and have a picture of all this red part. These are the red part. They should not land. Higher part. The green part, the blue part is the lower part. They land. And this time, NASA has improved the landing technology. Previously, in 2012, 9 years old, Curiosity don't have this technology. So now NASA have the terrain navigation technology. So as the parachute falls down onto the ground, taking the rover to the ground, and at the bottom of the rover, there are cameras that keep on monitoring the terrain and to match the image on the computer. And finally, they can land very fast. So it's blended very, very good. All right. The details of the landing, 7 minutes of terror, I can pass to the other guys. So this is the one. All right. So basically, 2 kilometers from here. So they assume they only off by a bit only. So you see here. So why is it important? Is this what they call Bright River Delta is where potentially you have what they call signs of previous life forms on Mars. Not necessarily alien lah, ikan bilis lah. No. Microbial life, right? So that's what. So that's where they landed very close. And of course, what? Then they will drive the rover along. So there's a guy in Jet Propulsion Laboratory. He's the driver, but he doesn't have a license. He will drive. You see, this is a kind of sorry, I go back. Now, this is a kind of a valley. It's got a high area, so most likely this is a low area. The rover will move here and come to the river, what they call delta there, and explore here. All right, but we know that in the first about 5 to 10 days, the rover will not do anything, just testing all the parts, make sure it's working. All right. No, I want to see the helicopter. Not yet. Patient. After 10 days, they will drive the rover to a place where football field size. They will drop the Ingenuity helicopter in that place, and then they will fly lah. All right. So the expected number of flights for Ingenuity is 5 flights. If more flights, better lah, but at least 5 flights they're going to try. All right. So now I just a bit more, and surprisingly, remember MRO. America has a orbiter around Mars now called Mars Reconnaissance Orbiter. Many years orbiting Mars, as the what you call Perseverance landing, did the parachute here live. The orbiter orbiting Mars took a video of it landing. Fantastic, right? So this is the guy. After this, I'll pass to the next guy. This is our Alan Chen. Now, Alan Chen is our EDL lead, entry descent landing leader of the team. So they are the one who designed it. Now remember, many of the people working on this Perseverance team is the same team members as the previous one, Curiosity, 2012. They landed on Mars. All right. So they are same. So he's the one that lead the team to make sure it lands safely. And now everything is landed safely. Job is done. So he passed over to the science team. So the science team are the scientists who start doing the what they call take all the experiment. Okay. So then okay, this is the 7 minutes of terror. So I will not explain. I will pass to the next person. So who want to explain? Go ahead. I'll stop presenting. Okay, stop presenting. Anyone, please? Come.
I can go lah, but I don't have the pictures with
No,
me
you
here.
can just speak. Can speak.
Okay. So at first the rover will be going into the Martian atmosphere very fast, about 11 kilometers per
Hey,
second.
never mind. As you talk, David, I show the picture. Is it okay? Okay.
Yeah, it's okay.
Okay, there you are, David.
Yeah. So at first it will go through the Martian atmosphere, slamming into it at 11 kilometers per second. It will generate a lot of heat. So that's what the heat shield is, the orange thing in front. So after it goes through most of the atmosphere, it's not going through so much heat anymore, it will drop the heat shield away and deploy the parachute. When it drops the heat shield away, you can see it will use the rover's cameras at the bottom, the terrain navigation camera, to look and scan and see, to scan the area to see which one is suitable to land. So it's actually scanning for the rough area and not the smoother areas. You don't really want to land at the rough area because it's very dangerous. It has a lot of rocks and a lot of hazard. So typically you want to land at the smoother areas. So it's so the rover will have a higher chance of survival lah. So once it has identified a suitable area, it will drop away from the parachute and the clamshell system, and it will fire the jetpacks basically.
Yeah, this one. Yeah, sky crane.
Yeah.
Continue.
Yeah, the sky crane. So it will use this sky crane jetpack system to guide itself to that particular area. And once it's about 100 meters above the surface, it will activate its It's a wire harness system where the rover and sky crane originally will be stuck together. It will lower the rover slowly towards the surface. So this system will go slowly towards the surface, and once the rover touches down on the surface, it will cut all the cables that is connected to the sky crane, and the sky crane will fly away to a safe distance to crash.
Yeah. So allow me to say some words. Now remember, the total weight of the Perseverance with the inside the stomach Ingenuity is more than 1 ton, 1,025 kilogram, very heavy as a car. Imagine they are dropping on the surface of Mars 1.1 kilo. So no joke, heavy. And another, I think the parachute is extra big one. So the moment the parachute is open, the what they call the rover inside the what they call this heat shield and the back shell with the parachute is opening at the speed of twice the speed of sound. So when it's open, there's tremendous jerk. So it's actually experiencing about 10 to 12 G forces. But luckily, all those components in the rover are tested. So very fast it opened the parachute. Continue, David.
Yeah, also some add-on from me. Yeah, to me, I think the really terrifying part is not of all of this. Is because basically all these maneuver should be conducted basically by the spacecraft itself. You see, because the signal delay. Everything, this one happens very fast. That means the time of all this from entry to landing maybe just a few minutes of time. But the signal relay, the signal from this spacecraft to Earth, it takes, if I'm not mistaken, this time is around 11 minutes, right?
Yeah.
Last time Curiosity 14 minutes. This time is about 11 minutes. So basically, when we receive the signal and we have to give back another signal for it to perform, it will be too late already. So basically everything, all of the maneuver, all this have to be done or precisely calculated and compute inside the system, and everything should be performed by itself. So this is the scary part, because everything is too fast. The process is too fast and we are too far away for the signal, for the communication. So actually this thing also happens in is basically all re-entry vehicles, include those astronauts. They are coming back from ISS also during the re-entry into Earth. Even the Chang'e mission Chang'e 5 mission coming back from the moon, the Tiangong mission, the astronauts from ISS also, they come back, they will experience. We have a technical term, we call it the blackout zone. So this blackout zone is where we actually, it's like we lost the communication for a short period of time. So this is the real terror part to me. I don't know how you all think, but then communication loss in flight is the worst thing we can experience to me.
Yeah. So just add on to what Lai said. So remember what Lai said is it takes radio waves 11 minutes to leave Mars to reach the Earth. but the time it takes to enter the Martian atmosphere at the top of the Martian atmosphere to land is only 7 minutes. That means what? That means on Earth you realize that now you get the signal from this the rocket that is entering the Earth's atmosphere. No, it's entering the Martian atmosphere. It's actually already landed. That means it will take 11 minutes for it to come, but 7 minutes to travel through the atmosphere. It's already landed, you still don't know. You receive the first signal that it entered the Martian atmosphere. So whether it landed successfully or not, you still don't know. You have to wait another 7 minutes. Yeah. So David, anything else to comment? Marcus?
Also, I have a fun detail. If you watch the JPL live stream, once the rover actually touches down on the surface, they will say these two words, Tango Delta, touchdown lah, basically.
Yeah.
So the meaning for this is basically the 6 wheels are on the Martian surface,
Yes.
but you don't hear them celebrating yet. What they really want to know is when the rover touches down, something may still not work. So what they're looking for is for the signal for them to cut away the cables, for the Skycrane to fly away, and for the rover to remain stationary on the surface.
Yeah.
Then only they start celebrating, like, yay, the rover finally landed.
And then the other thing is, you remember after that, half a day later, they have a post-landing press conference by NASA. So the scientists will ask a lot of questions by the press. So one of them asked Alan Chen. So Alan Chen replied that actually, while it is coming down to the Martian atmosphere, it actually transmits still after the high temperature phase, even it's still coming down by parachute, already it transmits the signal 2 ways, directly back to Earth, all right, with the low bandwidth what they call antenna, and then transmit a second one to the Mars Reconnaissance Orbiter, all right. So directly from the back to the Earth, so Alan Chen said there's a tone, that means a low bandwidth, just a signal, there's a tone. So from the tone, they heard that it's okay. The parachute open okay. From the tone of it, they don't know the full detail. Actually, there's a tone. Right when the burnout phase is over, right from after that parachute open to landing, there's a tone. They know because it transmits directly back to Earth. Low bandwidth. Okay, now we know that orbiting around Mars, you have the Mars Reconnaissance Orbiter, the American one. It would, yeah. So that means the rover will send the signal from Mars surface to orbit around Mars, and then this Mars MRO with a high gain antenna, powerful antenna, transmit back to Earth. And on Earth, remember, you have the Americans have the Deep Space Network, one big radio telescope in California, one in Madrid in Spain, one in Australia. So anytime at 24 hours, they can receive signal from this Mars. And at the same time, orbiting Mars, another two, one of them is called Mars Odyssey, another American orbiter sent into orbit around Mars many years ago. So that also can receive the weak radio signal from the orbiter, from the lander on Mars, back to this Odyssey, and Odyssey will transmit powerful radio wave back to the Earth. The third one is, of course, our trace orbiter, trace gas orbiter. So this is the European and Russian mission, also orbiting around Mars, and they also can receive the signal from Perseverance and relay it with high power back to the Earth. Okay. Okay, continue, or you want to go to the next picture or next topic?
Yeah.
We have a question from one of our audience in the YouTube channel, Mr. Tan.
Yeah.
He asked, what is the purpose of the activity Mars? So I guess he'd like to ask, what is the purpose of having this Mars exploration mission?
I think you can answer that.
Okay, go ahead.
Yes, please.
Go ahead.
All right. So there's actually 4 main objectives. They send the rover to this Mars, and one of the most important is, of course, to collect the Mars samples from, because Mars is a rocky planet, so there's rocks on the planet, so they want to collect a rock sample and examine it for signs of life. So, but they won't be able to bring it back, the samples with the rover. So so they plan for another mission to retrieve the samples from the rover by 2031. And another important objective is to demonstrate the technology to fly on Mars with the Ingenuity helicopter. It will be the first powered flight on Mars. And the other two missions are to find conditions suitable for life and to find like evidence of past life on Mars.
Yes. So I just generalize what Marcus is saying is, what Mr. Tan asked is, of all the planets, why Mars is so exciting? Because if you look at it, Mercury don't have air, very hot, even the moon also don't have any atmosphere, and very hot and very cold. So life to exist on Mercury, on this moon, very unlikely. Venus worse, very hot, all right? Hot enough to melt lead on Venus. So you look at all the other planets, maybe there's only one called Mars, where they are found in previous Martian mission, confirmed that previously Mars got a lot of liquid water. So where did the liquid water go to? So now if anywhere got liquid water, they have life lah. So they have a lot of those previous rover like Curiosity, Spirit, Opportunity, a lot of places on Mars they found the blueberries, a type of pebbles, blue in color is, but on the Earth, when you have blueberries on the Earth, got liquid water. So that means Mars got water and got things that similarly suitable for life. So now they land in a place called Jezero Crater. They will explore, I'll show you later, the place next to the Red River Delta. Hopefully, you will know lah, got life or not. But then the problem is, the proof is what? Engaging the Mars samples back to the Earth, like what Marcus said. But it will only happen in another 10 years' time, 2031. When this rover, Perseverance Rover, will collect all the sample and then put into those sample tubes and leave it on certain parts of on the surface of Mars. And then 2031, the Europeans and Americans will land another lander on the surface of Mars to retrieve those sample tube and then blast off from Mars back into Martian orbit and bring it back to the Earth. But there'll be another 10 years. It's only when you have the actual physical sample next to you that you can confirm. All right. They say that whenever you go and want to explore any object in space, the proof, the gold standard is get the sample from that object back to the Earth. There'll be another 10 years time. Okay. Anything else? Okay. We can go to the other parts. Sorry.
Yeah. So one questions from me actually.
Yeah, go ahead.
So before we proceed to the next topic, actually I have one questions. Actually, I more or less know the answer, but then we just ask so our audience can know more about this. So just now, Dr. Chong, you shared the first image from this Perseverance Rover, and it's black and white. So why this image is black and white?
Yeah, yes. Good question. Marcus, want to try? Why is it black and white?
Yeah, because because there's color cameras and non-color cameras on Perseverance, and like black and white pictures, they are usually faster to transmit to Earth.
So I'll show you. This is the hash cam, and this is the front part on the hash cam. This is the back part of another hash cam, and I'll show you the actual where is the location of the hash cam. Sorry, All right, wait. There you are. This is a hash cam. Okay, this is a low resolution. Okay, low resolution, and this is the view. This is a front right view. All right, front right view, and this is a color picture. And this is the first raw color picture from Mars. And look at shadow. And straight away they know that it's in the southeast direction. There's a problem to find out its exact location on Mars, because on the Earth, no problem. You stick out and put a compass. From the compass direction, you know where's the north, south, east, west already. On Mars, you have a problem. Mars do not have a strong magnetic field. Mars don't have a magnetic field, because the interior of Mars is dead, right? Don't have this tectonic activity, no lava, no volcano, so no magnetic field. So what they have is, they use on the rover what's called a gyro compass. So gyro compass is what they do in ships, in aeroplane, is you spin a gyro compass in this Perseverance rover, and you can actually detect the rotation axis of Mars, by spinning a gyro compass, a type of gyroscope, in Perseverance rover, you can locate what is the axis of rotation of Mars. And once you know the axis of rotation of Mars, you know north, south, east, west. So that's what they know. Why is it what they call southeast? Okay. So continue. Anyone? Marcus?
So just to further the questions a bit. So what is the advantages besides faster transmission of using the black and white camera instead of faster transmission? Any other advantages of using black and white camera?
Yeah. You want to answer, David? I can answer.
Yeah.
David?
I can give a point also lah. So like astronomy, like in astrophotography, most to pinpoint something lah, we typically want to use black and white cameras over color cameras because they give better resolution compared to color cameras. Because color cameras you need 4 pixels to get one color lah. So you have two green, 1 red, and 1 blue center. So you have 4 pixels to combine into 1 color pixel. But black and white, you only have the range between black and white. So like black and all the gray colors and then white. So you get better detail from the photo overall lah.
Yeah, take for example, I have 2 camera, 2 CMOS camera on CCD. One is 20 megapixel black and white. No? Second one is 20 megapixel color. But the problem with the color camera is that 20 megapixel, you have to share with many colors, you know. So basically, the resolution of the black and white camera is much better than the color camera. Although both are the same megapixel, right? Yeah.
All right, so thank you, Dr. Chong, David, and Marcus for the nice explanation.
Yeah.
So let's proceed to the next topic. Actually, this topic is actually what we have in the question in the comment section. It's actually a question from Naim.
Go ahead.
Our Naim. He asked, what is the things that Perseverance can do but Curiosity cannot? So basically, we are trying to discuss what is the difference of this Perseverance mission compared to all the previous mission. So anyone?
David, you go ahead.
Okay, I have two differences over here lah. So one of them is an experiment called MOXIE. What it's trying to do is take the materials from the Martian atmosphere, do some process, and hopefully create oxygen from the Martian atmosphere, because eventually we do want to send people to Mars. And because we need to breathe oxygen, we need to find out a way to produce oxygen on Mars also. So the MOXIE experiment is trying to figure out how do we produce oxygen on Mars, and test if this specific method works or not lah. And the other is like what Marcus said, sample return mission. So I like to call this the rover is pooping ah. Every so often the rover will drill a core sample from the ground and store it in this test tube, and the rover will leave this trail of test tube behind to hopefully in 10 years get collected again and return to Earth. So these two things are what Perseverance can do and Curiosity cannot.
Yeah. Marcus, any comment? What that Perseverance can do? Well, 9 years ago, Curiosity landed on Mars. It's still working, no Curiosity on Mars, but Curiosity cannot do. Perseverance can do, Curiosity cannot do.
Curiosity cannot collect samples. Perseverance can.
Yeah. Okay, so I'll just give my one in. Of course, this terrain navigation, what they call this technology, is only in Perseverance. That is the Curiosity landed not so accurate. So, have you heard what they in the press conference? The NASA scientist said is pinpoint landing of accuracy. They use the word pinpoint, very accurate. So they just off, I don't know how many meters only, you know. So very accurate. The accuracy don't have it. Now the other one that David mentioned, very important. If you look at the video, the NASA scientists that build this what they call this machine that collect the sample, they said cleanliness is the very hard thing to satisfy. They make sure that whatever they store in the sample tube, they bring back to Earth. There's no contamination in every step of the way. So they said that in the laboratory, they put in the furnace to bake the tube and make sure that it's very clean. The tube that you bring there must be 100% clean, super clean, right? And on the way when you bring back to Earth must be super clean, all right? That's it. And of course, there's this one, the NASA people don't dare to say, but I'll tell you, sorry, frightening. Is another COVID? No, terrible. Remember, in 1967, America, Russia, many countries signed the Outer Space Treaty. That is a lot of things about the use of outer space. At that time, they come out with a treaty to check on this testing of these nuclear weapons in space. But a lot of other things are in it. One of them is called contamination. You go to the moon, you bring back dangerous organisms. No? So when the Apollo astronauts come back, the first few Apollo mission return, they go into quarantine. No? Very, very stringent. No? So now the problem is they're scared that it will bring back dangerous, if they are life on Mars, bring that dangerous organism from Mars back to Earth, the human being, life on Earth don't have any defense against. Habis lah, mampus lah. So this very, very scared, you know. So this is called backward contamination. Go to Mars, Mars bring back to the Earth, backward contamination. And then one also, you make sure it's clean, is forward contamination. The tube that you bring from Earth to Mars, make sure you have to sterilize, go and bake it, sterilize, shine X-ray, whatever, so that you don't bring the Earth organism to Mars. You never know. Suppose one person is very, very silly, he won't do it lah. He just ate a McDonald's burger lah, and his hand got what, some grease law. He put in the sample tube lah, bring to Mars, and that what they call bacteria multiply law, and you leave it for 100 years. Wow, forward contamination. This also they have to prevent forward contamination and backward contamination. That's why they said this is very tough, you know, super clean. Yeah. Anything else that Pearson can do? Of course, if you compare all the experiments, I will show you all the experiments that this are carried by this Perseverance. All right. I think practically many of them are very different, no, from Curiosity, no. Okay. You look at the wait. You look at all the experiments, many of them only this can do. I don't know about this liar about Curiosity. So they have this rim packs, you know. So from Perseverance, you will fire the microwave that can penetrate through the surface of Mars to the layer below and scatter back and can know the structure and so on of the Martian rock below the surface lah. I don't know whether Curiosity got this. Hello?
I'm not sure also.
I'm not sure. So
I'm not sure, but I don't think so.
Don't think so. Yeah. And of course, you know, every mission, it looks like this is about 1,025 kilogram. Curiosity is less than 1,000 kilogram. Looks the same, but it's different. I think the thing is, we were having our discussion in our WhatsApp group just now that the wheels are also different, right? The wheels are also different. Yeah.
Curiosity only have an X-ray spectroscope.
Yeah.
Have an X-ray spectrometer.
Yeah, and of course we know that this one they designed for Curiosity is very fantastic. I really admire. Each of these wheels can move independently of the other 5 wheels. As it hit a rock, this will go up, but this won't go up. And then the rock will go here, then this go up, this one come down. So independently. Fantastic, yeah. And of course, here, in this Sherlock, this is like a robotic arm, fantastic, you know. It can do a lot of things, you know. It can drill and get the sample out, and then it can analyze it, and a lot of things it can do. Yeah, and then get a sample, put inside below the underbelly of the rover, and put it inside the storage space to be dropped later on the Martian surface. And of course, here a lot of things, so actually full of equipment, you know. All right? Yeah. So I remember in 2012, when Curiosity landed on Mars, that it's not a science report. I think it's an American newspaper report that what they landed on Mars in 2012, Curiosity rover, is the most advanced robot ever made by man. Like what Lai said, a lot of things it can do is autonomous, you know. It cannot send the signal back to the Earth. Send it back to Earth and get the signal back to the Earth. Like now it's 22 minutes. By that time, the rover will hit the rock, fall off the cliff already. So it's all automatic, man. So it's intelligent. All right, autonomous. It's a robot by itself. Yeah. Anything else to comment? Okay, I'll tell you. one big difference between Curiosity and this Perseverance compared to Spirit Opportunity and compared to Sojourner 1997 Pathfinder mission A, no solar cell for Perseverance and Curiosity. Why? Because they have a huge problem with Spirit Opportunity using solar cell. So now the dust fall on the solar cell panel of Spirit Opportunity. So half the power cannot go through, blocked by the dust. And later on, all the IT Opportunity, the whole solar panel blocked by dust, no more power generated by the solar cell. So this is a huge problem. So they overcome this. They build inside Curiosity, and in this Perseverance, it's a nuclear power lah. So it's our RTG lah. Radioisotope thermoelectric generator, and this it uses inside it plutonium dioxide, plutonium-238. So inside the plutonium dioxide, there's plutonium. So as the plutonium decay, it gives off heat. So not too much heat, but enough heat to generate about 100 watts of continuous power forever. Remember, nuclear reactor can work forever. If you say I think if Curiosity finally doesn't work, all the other components will fail, but the RTG of Curiosity will last for another few hundred years. So the 100 watt day and night, even night no problem. Martian night got power, day no problem. That's the advantage. But of course, the disadvantage is nuclear reactor can have nuclear contamination. Right? What happens if they launch it on the launch pad, some accident? So you contaminate the launch pad on the Earth with nuclear material. So that's the danger. Anything else?
So one questions from our audience from YouTube channel, again, Mr. Tan, is how the MOXIE actually works. The one below there that produce oxygen from Martian carbon dioxide.
Yeah. Marcus, you explain MOXIE, the exact details of MOXIE?
Yeah, and why they want to carry MOXIE? What is the purpose of having that in this mission?
Yeah. Marcus, you mentioned just now?
Okay, the purpose of MOXIE is to prepare for future human colonization of Mars. It works like this. So basically, it will take carbon dioxide from Mars to convert it into oxygen.
Yeah.
It's actually a test. So it's not it's a new technology, and it's sort of like Ingenuity and experiment.
Yeah. I just add on to Marcus. So basically, we know that eventually future man mission during our lifetime or beyond a lifetime, man must go to Mars, must get oxygen. So where to get oxygen? Mars atmosphere is 95% carbon dioxide. But there's a problem. Very thin atmosphere. So Mars atmosphere is about 1% the pressure of Earth's atmosphere. So it's very, very, very low pressure. But even then, 95% carbon dioxide is still a lot, right? So in other words, they say that the atmospheric pressure on Mars, on the surface of Mars, is equivalent to the atmospheric pressure on Earth at 30 kilometers higher. Remember, you fly from Malaysia to China to around the world, intercontinental flight. The aeroplane, the big aeroplane is flying at 10 kilometers high, 30,000 feet high. Not enough. At 30 kilometers, 30,000 meters, the pressure up there will be that of the pressure on the atmosphere, on the Earth, on the Mars surface. So very low pressure, but then still got a lot of carbon dioxide. So that's why they want to get the carbon dioxide, split the oxygen out, and get oxygen. What's the idea? So that future thing, what you do, human being go to Mars, human being need oxygen. You can convert carbon dioxide to oxygen on Mars, and you can use the oxygen to live on Mars for human. And at the same time, you got oxygen, what? Fuel. If in future you can make rocket fuel, anything you got fuel, the oxygen you can use as a fuel to make the rocket fly back to the Earth or do a lot of other things, because oxygen is fuel. You can use fuel on Mars to do a lot of things. So that's oxygen is important. But of course, I think that the MOXIE, the amount of oxygen produced in small amount. It's not enough for 1,000 people to breathe. No. Just enough. They want to test the technology. Yeah. So any other question, Mai? So
Yes.
maybe,
Yes.
later on,
There's.
after this question, I will go through all the slide. After the next question. Okay, continue.
Yep. So this questions is from our Daim,
Yes.
right? So he actually asked, which is why we need to send another mission to collect back the sample and instead of just drill another sample.
Yeah.
From YouTube. Our Daim asked, why are we sending another mission to collect and save the sample, the saved sample?
Yeah.
So why? It's actually, I understand the question this way, is why we split it into two mission of sample collecting and sample return instead of what we have like the previous China Chang'e 5 mission. They go to the moon, they collect the mission and they do the sample return. But for this time, this NASA, they split into two different missions, which another one will be performed about 10 years later. Why they do it this way?
So, Lai, you want to answer? David, you want to answer? Before I answer? David?
I can try.
You try? After that, I can try.
Curiosity is a very, very heavy and complex machine. So we don't, for the Sky Crane alone itself to carry a lander, an ascent vehicle, and this rover, it will be way too much payload capacity for the system to handle. So they choose to send the rover first, which is very capable and very advanced, and send another sample collecting mission, which also has a mass ascent vehicle later. So I think one of the reasons is also budget from Congress, because one of the reasons why they choose to wait another 10 years is because they need to collect enough funding from Congress to actually fund the mission.
Yeah. So I just add on. So what David says is correct. Just to add on the ascent rocket, added to the present Perseverance Rover is too much investment, too impossible. So they have dedicated mission. So this Perseverance is dedicated to explore Mars and so on, but collect sample and leave it on the Mars surface. Another mission dedicated to bring back the sample will come later. So that second mission to bring back sample, the lander is what? Very simple. If you look at the design of the future lander, it's a very simple design lander with a kind of a tube, where the small sample tube will push inside the big tube and it blasts off from Mars and will enter into Earth, into Martian orbit. And already in Martian orbit is the orbiter that sent the lander earlier, that dropped onto Martian surface. So that orbiter is waiting to collect the sample. So now this big tube from Mars with the sample collected, fire from the Mars surface, go into Mars orbit, and then join and transfer the tube like the Chang'e mission from the what they call the rocket in Martian orbit, from one rocket to another, to the returner, and that returner from Mars will blast off from Mars orbit and come back to the Earth. So this way, I think it's more successful. So dedicated mission. But then, just to answer, we know that every 2 years there's only an opportunity for the window to go to Mars. You cannot say, I go this month, every month I can go to Mars. Impossible. You have to wait for the window so that you save the fuel. So the window is 2 years. So in 10 years, you are given 5 opportunity, So it's not that 10 years means I can launch Mars anytime. So they have at least 5 opportunity to go to Mars. That's it. So any other question? Now, Lai, you allow me? I go.
I think Dr. Chong, you proceed with your slides first before we proceed with the questions.
Yeah.
We still have a lot of interesting questions to ask, but then we proceed with your part first.
So remember, he landed here, 2 kilometers from the dry river bed delta. Wow, so nice, all right. He cannot come here too high. He had to navigate this low area. Maybe he will stay there for some time, take sample. And then here, and then you say that in after 10 days, you start moving, and then you will find a place where you can drop the the helicopter Ingenuity, and they will find a place where it's flat for football field size, and they will fly the helicopter there for at least 5 times, if not more lah. More means shall be there. And then it's okay. So I continue. All right. And then so imagine this is not the where is now. This is taken from space earlier. So imagine right now the what they call persons here. So it will travel here, and then not only that, they'll go up the rim of the big Jezero crater. Now Jezero crater is named after a lake in Bosnia-Herzegovina in Europe. And 2 years ago, the NASA official went to Jezero town in Europe and gave to the mayor of the city a woman certificate, said that we are going to land on Jezero crater named after your town. She was so happy, all right? So you're going to move, even go beyond the rim, fantastic, all right? And then this one you have seen before. So before the descent stage, with the sky crane holding the rover, this is 2 meters from the ground, all right? I can see the wind blowing. The wind doesn't mean that, the wind caused by the descent stage rocket hitting it and just before. And here this is of course the cable holding the full weight of the rover, but this is the umbilical cord. That means from the descent stage, you take a lot of data, take a lot of pictures, and feed it back to this rover. And then when it hit, the moment it hit on the 6-wheel hit or confirm, then automatically you cut it off, and then the umbilical cord also will drop. And then the descent stage will fly very high, far away, and drop back on the surface of this Mars, so that you will not fall back onto the rover. Right? Now this is the first raw color picture from Mars. This is the second picture from Mars. The first one is like what Marcus said, the black and white picture. This is the first raw color picture from Mars. So nice. Okay. And this is the front right wheel. Okay. And this is the HES camera. This is where they took the first picture. And here is the, you can see many kilometers away the rim of the Jezero crater. Fantastic. Okay. And then now you see the Ingenuity in the laboratory is just below the rover. Wow, so nice. Ingenuity. All right. And in the Ingenuity, this one, it right now is open up. It doesn't mean it carry like that. It's all folded. It's all folded, Ingenuity, and covered by this kind of what they call shield cover. All right. Inside is Ingenuity. I'll show you how they release Ingenuity. Then already on the Martian surface, this cover will drop, point, it fell away. Ingenuity is here. Then they will open up Ingenuity. See how they open up. Why they do that? Save space. So only a small space to carry Ingenuity. Then Ingenuity will slowly open up, You see there, the leg opening, Then this is the scientist or engineer. The leg opening, This is the 2 blades, All right, opening. Going to land. Then land it there. And after that, what to do? After that, the rover will move away. I have a feeling it's like this. It's to be more accurate. Sorry, allow me. Okay. Once this cover drop, the rover will move away. And move away to a place that no more rocks, no cover. And then only they will open up this Ingenuity, and then it will be on the surface of Mars. And then the rover will drive a second time away, so that the Ingenuity on the ground on the surface of Mars is not obstructed anymore. Then of course Ingenuity is out. After some time they will fly. Okay. I remember they will fly maybe after 10 days time only they'll fly. Okay. So this fly, and this you have these 2 rotors, and you see on top here you have this solar cell. So sorry, when Ingenuity is inside the rover, it gets its power from the nuclear reactor of the rover. But once Ingenuity is outside, it only gets its power from the solar cell, right? And not much, solar cell. So in other words, the solar cell will charge the battery of the Ingenuity, and the power, then only it can fly, all right? So this lift off, fly, all right? And it seems each time it fly, Ingenuity can fly only for 1.5 minutes, only 90 seconds. That's good enough. Not enough power. So I mean, for 30 minutes, all the power in the battery is drained. So it must land, and hopefully sunlight falls onto the solar cell, charge up again, and after charge up, and then go for the second flight. All right. And then just by the way, we know that in 1985, the Soviet Union launched 2 spacecraft, Vega 1 and 2 on Venus. And they also dropped on Venus balloon, 2 balloons. So this is not the first time that mankind has put a kind of automated flight, autonomous flight. They have done it before, Russia. But this is like a helium balloon. No power. But for Ingenuity, it's powered flight. The first power flight on another planet. But the balloon on another planet has done before by the Russians in 1985. All right, released 2 balloons in Venus. So now we'll go and look at Ingenuity. Now this is actually a visitor to the laboratory in JPL that made the Ingenuity. This is the chief scientist. She's a woman, engineer from Myanmar. And she's a leader. You look at the video, very exciting. So now he is in the laboratory. So this is another scientist engineer, our Balaram. So he's actually from Chennai. Okay, are you American citizen? Originally from India or Tamil Nadu, Chennai Okay. So now these are the 3 top scientists of Ingenuity. So this is Mimi Aung, the leader, Balaram, and I think this is from Eastern Europe, but all American. So they are the one on the Mars helicopter. So they developed it. And the height that is going to fly, the pressure is going to fly on this Mars is 6 millibar only, about 1% of the Earth's atmospheric pressure. And it's compared to the Earth's pressure, it's the pressure at 30 kilometers high from the Earth's surface. No joke. All right. So Ingenuity is going to fly on Mars at the pressure on Mars equal to 30 kilometers air pressure on the Earth. All right. And this is how it looks like. It's very small, And there's one master said, you look at one of the counter-rotating blade, it's about like 5 dime, D-I-M-E. 1 dime is like 50 sen. Very light, composite. So this blade is about 50 cent coin only. Another 50 cent coin. And this is counter-rotating. If this top one is rotating clockwise, the bottom one will rotate anti-clockwise. Why? So this is it. And on top is a solar cell. So it's showing the size on Ingenuity, very light, So this, so now, why do they have the counter-rotating rotor? In a helicopter, this is rotating, say, clockwise. Because of that, Newton's third law comes into play. So in the shaft, this inside the rocket, in the helicopter, this is rotating clockwise. So the body of the helicopter will rotate anti-clockwise. The rotor clockwise, the body of the rocket anti-clockwise. So to overcome it, there's another small fan here, another small rotor to push the air such that it will block it, such that it will just block the counter-rotating force. So finally, this helicopter is always pointing in the same direction. But now you have a problem in the engineer helicopter. The engineer helicopter, you cannot build this thing with a small thing. So what they do is they follow what they do in some of the Russian helicopter The Russian helicopter where one of the rotor clockwise, the other rotor anti-clockwise, without the third rotor here, that is enough to make it a leap. All right. So the whole weight of Ingenuity is on Earth 1.8 kilogram. But remember, on this Mars, the gravity is weaker. So there's a problem in launching Ingenuity in Mars atmosphere, thin atmosphere. So the rotor must turn faster to have a lift. But advantage for Mars is Mars gravity is 38% of the Earth's gravity. So Ingenuity will be lighter on Mars. So Ingenuity is weight about 700 grams only, 0.7 kilogram, right? So now like this. So now the thing is, they even thought of using part of the component for Ingenuity aerogel, which is light. But I find no need. That their technology is good enough, right? And so now they tested the Ingenuity in a big vacuum chamber, So this is a scientist from originally from Eastern Europe. There's a 20 feet diameter chamber where they evacuate the air until it's 1 atmosphere pressure, and they tested it inside. So now they put in the air. So the engineers go inside there and put in the Ingenuity, and then they go out. They close the big door, and the huge vacuum pump will pump. I think no need to have diffusion pump. Just rotary pump is good enough. Rotary pump can pump to 10 to the power of -3 No need to such a low vacuum. So pump to 1% Earth pressure enough. So then it's in the vacuum. They apply this in the vacuum. Very smart, You know what they do is 1 atmosphere pressure inside there. they're launching, they're flying this 1.8 kilogram. But now the thing is how to simulate the gravity on Mars 30%. So really, there's a cable here pulling up, always pulling up on the helicopter vertically up, and you just counter balance the Earth's gravity such that if there's so much weight here, 30% of the weight is pulled up. So they can simulate the Martian gravity here in the Earth, on the Earth, right? In 1% atmospheric pressure. Very nice, all right? So it's going up. So now as it flies from the, can I continue, Lai?
Yes, please.
So when they fly off from the Martian surface, what? So remember, Ingenuity is a technology demonstration. It's not going to take data. The idea is not to take data. Nobody has flown a helicopter. They want to see whether it works or not. So it's a technology demonstration. So then, for example, when you fly, a camera will snap, low, all right? And the picture in the software in the Ingenuity will transferred by radio back to Perseverance. And Perseverance it can send the information two ways back to the Earth, one directly by the X-band transmitter, which is a low bit rate. More better is Perseverance will send to the Mars Reconnaissance Orbiter orbiting around Mars, Trace Gas Orbiter orbiting around Mars, Odyssey Orbiter orbiting around Mars. So these three orbiters will have receiving high gain, what you call transmitter, transferred back to the Earth and detected by the NASA Displace Network. So like this. And it seems the first picture that Ingenuity will do is selfie. Ingenuity will take a picture of itself with Perseverance next to it. So we are waiting for the selfie. Stay tuned, right? And then, of course, we know this is the sunset on Mars. Remember, Mars is opposite to the Earth, no? Sunset on Mars, the color of the sun is blue, all right? But imagine the daytime, let's say at midday, midday, if you look at the sky on the Earth, on midday, the sky is blue, isn't it? No. On Mars, the sky during daytime is red. But the sky in sunset and sunrise on Mars is blue. That is imagine when the Ingenuity, Perseverance will look at blue sunset on Mars. Of course, it was launched by our Atlas, this Atlas 5 rocket, all right, from in July from America, all right. So now I will go to the next few pictures. Sorry, and that will be end. Okay. So these are the experiments. I just mentioned only. I won't explain more. So it's our planetary instrument for X-ray lithochemistry, PIXL. Then the radar imager for Mars subsurface experiment, RIMPAX, the one will give the radar and get the structure of below the Mars surface. Then Mars environmental dynamics analysis. And by the way, all these equipment are not necessarily built in America, no? It's built in Norway, built in Spain, and so on. And this MOXIE, like Michael said, all right, this being in America, and of course SuperCam, MassCam, and so on, all right. And of course, this important one is the ARMA, scanning habitable environment with Raman and luminescence for organics and chemicals. Okay. So now the thing is, wait a minute. The thing is, one more they didn't mention here is the microphone. First time they are listening to Mars. I was very surprised. Why the Americans? So why don't they think of sending in so many years, the past 25 years of the lander and the rover on Mars? Why don't they put in microphone? So microphone very cheap, what? So finally they put microphone. But microphones, I think, 2 or more microphones on the rover. All right. So now the last one is I was a bit late. Many people in the world have sent their name to Mars. What is this? So on internet, it can be anywhere in the world they accept it. So they accepted about close to 11 million people from around the world. The names of 11 people around the world sent to internet, to NASA, and in it they use the what they call this microelectronics technology. They inscribe into 3 silicon chips the names of the 10,900,000 people. So some people say, "Oh, my name is on Mars." Yeah, on the Mars, no. And everyone who have this on Mars, good luck. You got the certificate. Your name is on the microchip, now on Mars, and you put now boarding. So nice, They really promote for the public, right? Public. Okay, that's all. Lai, continue.
Yeah,
Right?
so we continue with the Q&A sessions from our comment session in YouTube and Facebook. So we jump to Facebook for a while. So we have Chong Seng asking us this question. Mars is within the so-called Goldilocks region, which is not too hot and not too cold for life, right?
Yes. But that is
Yes,
only part,
yes.
but that's only part of the question. What is the full question?
Yeah, that is the full question.
Oh,
I repeat, Mars is within the so-called Goldilocks region, which is not too hot and not too cold for life, right?
Yeah.
Yeah, so the answer is yes. So we proceed with the next.
I just add on. It's
Yeah.
not complete like this. The Goldilocks zone or the habitable zone is actually somewhere beyond the orbit of Venus. That means you have the Sun, Mercury, Venus, and a bit further from Venus, habitable zone start. All right, and then it reaches to the orbit of Earth, also a habitable zone, and continue to Mars. But before the orbit of Mars, is the end of the habitable zone. So Mars is just outside the habitable zone, just outside. Yeah. But of course, we know that when you say habitable zone or not, it also depends on the behavior of the sun. Right now, the sun is in the middle age, which is a yellow dwarf. Its size is like that. In future, the sun will slowly expand to become a red giant. So imagine when the sun becomes the red giant, then the habitable zone is no more between here, just beyond Venus to just before Mars. Then the habitable zone will shift further away to Mars, and maybe from Mars to Jupiter is habitable zone. So it also depend on the sun also. So right now it's like this. So now the problem for the habitable zone on Mars is this. Now Mars got liquid water. So where did the liquid water go to? Now there's a problem for Mars. You cannot avoid it. Mars is gravity is weaker. Why Mars gravity weaker? Because the Mars mass is smaller than the Earth. Because it's smaller than the Earth, the gravity of Mars is only 30%, 38% of that on Earth. Imagine you weigh 100 kilogram on Earth. On Mars, you weigh only 36 kilograms. So the gravity of Mars is not enough to hold the light gases like on Earth. So for example, on Earth, hydrogen, helium released on the Earth's surface, after some time, some years, it will be escaped. We have reached the upper atmosphere, this escape velocity will leave and lost from the Earth. But heavier molecules than this what you call hydrogen and helium, I don't know, maybe some of the light gases on the Earth can be what you call trapped by the Earth's gravity. But on Mars, many of the gases will be escaped. So we ask ourselves the question: is water molecule trapped by the Earth because of Earth's gravity? Yes, Earth's gravity can hold water molecule. Gravity can water molecule be held easily by the Martian gravity? We don't know. We have to make a calculation. It can make it. Maybe some of the water evaporated from Mars. Mars gravity is not strong enough. Some of them can leak out, keep on leaking out into space. So that means maybe if you have enough liquid on Mars to replenish on Martian surface to replenish the water evaporated into space, that there's enough water in the Mars atmosphere. But let's say if the Martian gravity cannot hold water all the time, always got leaking, maybe the water is lost into space. So that's the problem of Mars, weak gravity. Any other question?
Yes. So this is a question also by Daim, and is slightly related to what we discussed just now. It's actually extended from what we discussed just now. Just now Marcus, I think, did mention that they will send another mission in 2031 to collect back the sample of the rocks from Mars, right? Yeah. So Daim commented that, so is it safe to say in 10 years time we will only send another robot, not human?
That depends. SpaceX is planning to send a man to Mars in the next few years, in the near future. So we are not sure if they will follow through with their plan and succeed or not. So it's difficult to say.
All right.
David, I got a long answer for this. David, you can answer. You can answer.
It's very hard to say because it's very hard to predict the advancement of technology and how companies advance with their plans, because they will surely have some roadblocks along the way, and how fast they will solve the problem, we cannot say also lah. So there's a very, very big question mark there. So we may there may be humans on Mars in 10 years and they also may not be. It's very hard to say.
Lion, you want to answer? Lion? Oh, let me try. Now, I will say that my answer is definitely no way in 10 years' time you can even send a rabbit to Mars and come back, bring the rabbit back to the Earth safely, still living. Impossible. Remember, mankind walked on the moon July 1969, 52 years ago. More than half a century. Have they able to go back to the moon again and start a moon base? Difficult, expensive, So it's not the problem of sending a man to Mars and coming back. He must go to Mars. Sorry, must drink water. No. Sorry, must bear also. No. Sorry, So you must have life support, breathe oxygen. And then whatever he do, got life not easy. Much difficult. Much more easier to have robotic exploration of Mars. So many people will say, scientists say that wasting a lot of funding to send manned mission to the solar system. Robotic exploration is good enough. You want to bring back sample? Never mind. Send robot to Mars, to the asteroid, and bring back the sample from them. So that's it. So I would say that because you see, the resources of a small company like SpaceX are nothing compared to sending to men to Mars and back. Impossible. A few years time, it's totally impossible. It's like a dream. So what I'm saying is, step by step. So we already know for many years to send a man to Mars successfully and back to the Earth still alive is go to the moon first, build a moon base, right? And from the moon, you get the resources on the moon, you get the energy, the what you call the steel and the material there, build a rocket on the moon and launch from the moon with the lower gravity, much cheaper to launch from the moon to go to Mars and come back. But that will take a long time, right? That's the thing. So I'm sure this is a big question still going on. More effective to send robotic mission than human mission. Yeah. So in 10 years time, I think definitely cannot. But they can bring back a robotic mission, go onto Mars and bring back the sample from this Perseverance mission. And remember that China also have a kind of Martian sample caching, They also want a Martian caching one. So maybe that means that once you have cached the Martian sample in the sample tube of the Chinese, they also have a future mission to bring back those sample tube in Mars sample, right?
So I think it's fair to comment this that now is actually the competition between China and American in Mars.
Yeah.
Yeah, and also I think Dr. Chong, your answer also answer this question from Mr. Tan, which is why we cannot directly send astronauts to go to Mars to collect the sample. So also I like to add on a little bit of comment is that to send any human mission to any planets or any celestial body we have in this solar system, we need to have a lot of tests before we could actually send anyone or any living organisms on Earth to any other celestial body we have in this solar system, because we need to test the system. This one is a two-way ticket. If we send something, especially we send a human, it's a two-way ticket. We cannot have a one-way ticket. You can go but cannot come back. So you need to test your system. I think there's still a long way to go before we could send actually a human being or astronauts to Mars. We need to make sure our system can come back safely. And then we need to have the life support system. So we need to make sure that we can survive there. Our equipments can support our life over there, because we know that in ISS, our astronauts can do spacewalk. The spacesuit costs millions. But then whether this spacesuit in space works the same way, or the environment it can survive under the harsh environment in Mars, we're not sure about that. So this is my comment on why we don't directly send astronauts for the time being, and we still need a long time. So the life support system is the most challenging part.
Yeah, I have a question for Rai.
Yeah.
Currently, how much does it cost to send up from the Earth's surface to orbit around the Earth, as they say, at the height of Ingenuity station, 1 kilogram? How much does it cost?
Different country, they cost different.
Roughly the number that you know. Must be very accurate.
The number around, if I'm not mistaken, is 50K, is it? 50K.
US dollar.
50K or 500?
US
dollar.
Okay, I'll repeat.
Yeah.
What I said is to send 1 kilogram from the Earth's surface to about 400 kilometers up in space to go to ISS. To bring up 1 kilogram, you need to pay 50,000 US dollar, which is 200,000 ringgit. Now a person weighs 100 kilogram. Imagine Masai weigh 100 kilogram. All right. 1 kilogram is 200,000 ringgit. No, 100 kilograms is what? Wow, many millions. Tens of millions to the just into Earth orbit to go to Mars, come back. 1 kilogram maybe 100 million ringgit. Now just to let you know, we check. The Mimi Ao say that her team, the development cost, everything, to build and test the whole rocket and the Ingenuity helicopter is 80 million USD times 4, 320 million ringgit for the small. And I said, imagine on Mars that is weighs lighter. On Mars, that helicopter weighs about 700 grams, 0.7 kilogram, 320 million ringgit. Expensive, you know. That's why I say its weight of the helicopter is more than its weight in diamonds. No joke to send a human being at this stage cannot. But of course, we have been reading a lot of science fiction for years and years. I hope I'm not been carried away here. We have been reading science fiction for a long time, even before men went to the moon in 1969. Science fiction writer around the world, famous one that you read, Arthur C. Clarke, British, Isaac Asimov, American, and so on, they already say that man has explored the whole solar system. Go to the moon first, then go to Mars and do asteroid mining with all the resources in the solar system. You go, and then the future humanity will never be born on the Earth. No, they're born in the other parts of the solar system. And after that, what? Some of the more enterprising science fiction writer, what? Go to the stars, hyperspeed drive, and so on. And after that, go to the stars, what? Explore the Milky Way galaxy. And after that, more fantastic and more crazy, explore the universe lah. You have hyperspace travel. So I subscribe to this, that man's destiny is not on this small point in space called the Earth. Man's destiny, minimum solar system, right? Go to the moon, go to Mars, Venus, and then explore, go and land on the asteroid, and so on and so on, right? So remember this famous story in science fiction. I don't know who wrote it. Famous story. Many years from now, hopefully not thousands of years from now, maybe a few hundred years from now, there's a father and son on one of the moons of Saturn, all right? And the father actually came from the Earth, but went to the moon of Saturn and settled there and started a family there, and then got children. And then the father and son together on that moon, looking back at the Earth. You know, hey boy, you look at the small blue dot in space. We came from there, you know. That the father come from there. Of course, the son was born on the moon of Saturn. In future, it could be like this, or even more fantastic. From the nearest star, you're now in the star Sirius. All right, Sirius. I don't know whether got Sirius A and B. Don't know whether got exoplanet. Say got exoplanet. In future, humanity go there, and then we look back at the star. This you cannot see the what they call the Earth. You can see I can see the sun. You know, we originated from that yellow dwarf star. So demon we come from that star. The future of like this and you never know. Maybe aliens are doing it around the world. They're exploring the whole universe already. All right. So sorry, the whole cost of the Perseverance, build the rocket, build the rover, build Ingenuity, and also operating costs. You know that the operating cost of the rover is 300 million USD, or 1 Martian year, 2 Earth years. The operating cost to run Ingenuity is 5 million US dollar, 20 million ringgit for 2 Earth years. No joke, you know, expensive. So the whole what they call Perseverance mission is 2.7 billion be the Bangkok dollar, or close to 11 billion ringgit. Oh, no joke, lah. Very expensive. Very expensive. No joke. So,
So
anyone?
we have next question, also from Daim. He asks, if we want to look for other solar system body to land on, which one will it be?
Can answer? Marcus?
Yeah, anyone?
Yeah? Yeah? Okay, I'll try, huh?
Yes, Marcus.
Marcus, right?
Would you like to try?
On your microphone. It's off. Microphone, yeah.
Yeah, I'm not sure.
Right, on the try?
Yeah, actually, other than Mars, I think the moons of Jupiter, the moons of Saturn are good options for landing also. Even I have a thing slightly further. I think Pluto sounds a good options as well.
I just to ask, like, is the question finding other exoplanets are suitable for people to go, or in the solar system?
No. In the solar system, any other body other than Mars. That means like maybe Venus, Mercury, or other thing within this solar system, which is another option we can select to land.
Okay, let me try. If you look at what we know now in the history book, even long before they went into space, we already using telescope equivalent Earth. We already know the condition of other planets. Is there any other planet in the solar system other than the Earth which is similar to Earth's condition? Answer is no. Mercury, hot, no atmosphere. Venus, very hot. All right. Moon, no atmosphere. Weak gravity, or extreme. If you look at all the other planets, I think the most similar one to Earth is actually Mars. But Mars, of course, is what? Smaller, weak gravity, and what? Cold, very cold. Very cold, right? And so on. So, what they call? So, in other words, we cannot say that we must find environment on an object in the solar system which is very similar to Earth. So, however different from the Earth, can we make it habitable? Answer is yes. So, right, let's say on the moon, like you see a lot of those science fiction movies, a bubble on the moon base, you build a big bubble, a glass protection. You can see the star. Inside, you put 1 atmospheric pressure, but the gravity is 1/6, right? So you can do, or even when you tunnel in, you build kind of habitation below the surface of Mars, below the surface of asteroid. You can do it. So I would think the man's ingenuity, very, very, very clever. Anywhere in the solar system, they can find a way that they can survive on. They can find a way, right? Even, for example, when they said they want to send the James Webb Space Telescope into space, I said, how come? Space, one side in the darkness, very cold. The other side in the sun, very hot. How to do it? No, the NASA scientists, they got idea with an umbrella, with a shield. So with the umbrella, they block the sunlight, and behind the umbrella in the shade, they put a telescope. So that means man's very clever. Somehow or other, they can think of a way to overcome. So it's not easy, lah. Of course, to survive, what? First of all, you must be able to get easily available energy sources, water, right? Oxygen, industrial materials, and so on. Slowly. Okay, we have already seen a lot of science fiction stories. The many science fiction stories I've seen is, you know what they have on the moon? Like a big city in a bubble. Got hospital, got university, got golf course, got all kinds of anything on the Earth you have in a city of 100,000 people, they build on the moon. And there are even stories about the moon is moon sports, Can you imagine you do Olympics competition on the moon, totally different to the Earth. You hit a golf ball on the moon, it goes 20 kilometers away. You have to attach a radio transmitter on the ball. So you swim in the moon. How in the water? Imagine it's all under pressure, right? You are 1/6 G on the moon. How do you swim? So all kinds of things, Now the other one, this dime didn't go to the extreme. The extreme is this: it's not to find anywhere on the moon surface, Mars surface, asteroid for people to stay. It's in space itself. That means you have a kind of orbiting, the kind of big spacecraft orbiting the sun between Earth and Mars. It's always in space, and the huge ball. The ball is maybe 10 kilometers in diameter, just like the Death Star, Darth Vader. All right. Inside it, people are living inside it in 0G. Also got science fiction story. And they say that if they have that type of city in space, you know how the swimming pool is like. You have a swimming pool. Imagine in a swimming pool, it's a 100-meter diameter water drop. Imagine a water drop that's 100 meter in diameter, inside full of water. Of course, outside is vibrating a bit. And you try to swim inside there and do snorkeling inside. 0G. Possible. So it's also possible to stay in space itself where there's 0G. Possible. Yeah. Any more questions?
I think we can also, instead of doing need so much work to do on this, I think another maybe a long term thing that we can do to stay on all these other planets, maybe we call terraforming. We try to change the landscape and the environment of the planets. But then that one will have to study we study the environment of the respective planet first before we could actually have anything we have the solution for terraforming.
Also be very expensive because need a lot of resources from Earth to carry to the other planet.
No.
Yes.
The whole idea, Marcus, is to go to other parts of the solar system. We don't take the resources from the Earth to go to Mars. We use the available resources there, or you transform it there. If you cannot take from the Earth there, remember what I say? Every kilogram is 200,000 ringgit, you know. Impossible. 1 kilogram is 200,000 ringgit. Impossible. You have to use the material in that place. All right? I just want to add on.
But what I meant was that we will need to transfer like the technology there to like melt the polar ice caps on the Mars.
Yeah, I know, but you cannot. Whatever you want to go to Mars, minimum amount you take to Mars lah. But whatever you want to grow many times more, when you build a city there, all the materials is from Mars. You cannot bring from the Earth. Impossible. Expensive. Now the other one is actually last time in some of the session on the other AstroCafe session, I also mentioned one big driving force. You now know, of course, SpaceX. SpaceX is one of the most recent one, much earlier. Many companies have been set up to do space tourism, to go and do asteroid mining. There are many companies in the world, especially in America, no? But so the main driving force is what? Money, 钱. So many of these companies, they say that, do you know that mankind is so advanced now in space exploration that we are now imprisoned in a small dot called Earth. All the money you make, all the billions of dollars people make is only for one point called Earth. Imagine there's a billionaire on Earth. He want to exploit don't say exploit the whole solar system. He want to exploit 1% of the asteroid belt lah. He can become a trillionaire. So in future, mankind is not going to exploit the resources of a tiny point called the Earth. The mankind is going to exploit the resources of the whole solar system. From Mercury to Neptune to Pluto to the Kuiper Belt. Yes, can you imagine? So that's why the driving is what money, anything got money, people will try to do one. So that's it lah. So, but of course I say, give enough time. 10 years cannot, 30 years cannot. Maybe after a few generations can. Then there will be I think the first thing should be this. A permanent small moon base on the moon. First thing. Then later on spread more. Then later on go to Mars and so on. Can. So I fully subscribe to it that man's destiny is no more on Earth lah. Should be the whole solar system. Should be the whole solar. The first step.
There actually got some people believe that we should focus on Earth problems rather than like go out into space.
Yeah, I think you have a point there. Like you want to explain? So I would say like this. If the so-called European explorer with a sailing ship, Christopher Columbus, he's actually a Italian, Christopher Columbus, but he was with the king and queen of what they call Isabella and Alfonso of Spain, give him the money to build the sailing ship to go around explore the other places in America and make Spain very rich. Before the British become rich, it was Spain that explore the world. So at that time, Spain got war, got war in Spain. Europe got war. The Spanish were fighting. So the same argument can be said. Why you want to spend money to build so many ships for Christopher Columbus, but the money can help us in Spain itself? So the idea is this: the whole thing is this, because the chances are to make money to go to the so-called New World. Actually, Christopher Columbus is supposed to look for the India, but the other way, opposite way. But when they land there, they couldn't see India. That's what they say. The Indians, the Red Indians are called Red Indians. They thought they're for India. So in other words, it was there. That's why they go. So because it's there, we go. Even got problems on Earth. You look at the history of mankind. When they always go, they find something, and the mother country always will benefit. So the first thing to happen, they exploit the moon resources. Are tremendous. But luckily, one more thing is, 1967, Outer Space Treaty is very clear. No single country owns the moon. You cannot say go to moon. Do you know in the world, in America, for example, there's still a lot of unexplored area. I'm a gold prospector. Let's say I prospect for titanium. I found titanium there. I can get the proof. I can make a claim for this hectare, and then they'll prove. So I own this land. In the moon, cannot. The moon belongs to the whole of mankind. I think it applies to the other parts of the solar system, belongs to the whole of mankind. But the problem is this: as mankind spread in the whole solar system, let's say now on the moon, a lot of colonies, China, America, many countries, you think they will follow the old rule that nobody claim the moon? They'll sure fight one. I come to the moon 200 years ago, no. I built my city, and you just come in last year. So this part of the moon is mine, It'll be like that, no. So because it was claimed in 1967 where men have not even been to the moon. But now, going to the moon, going to Mars, so a lot of complication will come on. Sure. I'm not sure if, let's say, one of the SpaceX venture on a small asteroid, they found that is full of, let's say, half of it is actually magnesium. Imagine the rock the size of Penang Hill in space, in the asteroid belt, half of it is magnesium. It's worth how much? You think SpaceX will simply give up the ownership? No. It belongs to me. I pay for it. In future, I tell you, sure got problem, man. And you know what? A liar. You have seen a lot of Star Wars picture and so on. I used to read the science fiction book even earlier. The future wars in space is because of this fighting over land ownership. So this asteroid, a lot of minerals, another the company is between companies take over, and finally they don't agree. They fight the war. They fight a solar system war. They are in other words, that's a united. There's stories like that. United Nations of solar system. Mars, one gang, and then Venus, Earth to another gang, and the whole solar system divided 50-50. Solar system war because of this fight over the resources and so on. Like this, in future. But this is all still in the far future. So, but now,
So one question from me actually is this: we just now actually did discuss on one of the mission is to study the life science in Mars. So what if this is a what if question? So what if we really discovered some living organisms in Mars? So how are we going to deal with it?
This is what we have been waiting. When I started reading science fiction in 1963, Form 1, already a story like that. Once they find, that time they never say Mars. Once they find that somewhere in a solar system, whether on a planet or asteroid or even in space, that is confirmed that it's life. Life doesn't mean ikan bilis, or a rabbit. Even microorganism. If found it's confirmed that outside the Earth, say on Mars, there's life, then I use the word, the floodgates are open. Then all the science fiction writer will throw all the caution to the wind. Life on Mars confirmed. No, life in the universe is possible. So now I would say that this Jezero crater, the dry river bed delta, is very important. If they bring back a sample, hopefully, I would say, the geolog will drill, they shoot onto it X-ray, UV light, and laser, and from the light scattered back, you detect the elemental abundances from the vaporized material, and also it will the Mars camp can shoot the laser to the rock far away, and the vaporized material will give the spectrum, the element. Maybe hopefully, and also it will drill, you drill the rocks in the dry riverbed, and hopefully on many dry riverbeds on the earth got what? Stromatolites. They are the fossilized cyanobacteria, the microorganism. So even before the sample return mission in 2031, even from this Perseverance, they are like very good evidence. Hey, you look at this thing, look like stromatolite, the optical picture, the X-ray picture, already is a good proof lah. But the gold standard is actually bring the sample back to the earth and study. So we hope, you look at the dry river data, very, 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 very enticing, very, very fantastic. I'm very sure that those life scientists, who work in NASA, were told that Perseverance going to land on and explore that dry river data. You know what they do? Hiya, we hope can find life there. We hope because you see, imagine you go to many parts of the world, Australia and so on. These are stromatolite, these are fossilized, or even in the sea, in the big river, the microorganisms are deposited on the rock. Not coral, stromatolite. They are glowing. You look at it, you know it's stromatolite, and you know that the living stromatolite. Why? Called liquid water. What? So if they were to look at the optical picture of those samples from on the surface of the dry riverbed, which I'm very sure the dry riverbed don't have any living microorganism now, don't have, but they have evidence of past living microorganism. So once you have that, confirm, then humanity's brain will open. We are no more alone. And this also has been described by science fiction author. The moment they confirm that there's life in the universe, especially you listen to the radio telescope from a star, and there's intelligence signal from received on the earth that there is intelligent people on that star, or on the earth, or on the planet orbiting the star, transmit earth. You know what's going to happen? There are life outside the earth. Humanity will not fight anymore, become friend, bite. Why? Hey, they're scared, got aliens can attack the earth, So then all the problems of the earth will be solved. No more fighting. You must unite. So they said that if they have found life in the universe, and let's say especially detect an intelligent radio signal from somewhere in the Milky Way galaxy that they are intelligent, and let's say the signals are a bit nasty. Hey, your earthling are not advanced, they are very advanced. Given time, they are going to conquer you. So then what? Humanity will unite. So that's one of the consequences. Don't say radio intelligent radio signal. Just to find life on Mars. They have got life in other parts of the solar system also. Life on the exoplanet. What about the life on intelligent? Okay what the intelligent and nasty intelligence, nasty extraterrestrial? Then we have to unite So this is a big implication. So this discovery was not only scientific implication, cultural, religious, all kinds of anything that do with man is involved. For example, you have seen a lot of story about some of the astronauts or what in future traveling interstellar space meet some alien. The first thing I ask is, do you believe in God? Who is your Jesus Christ? And so on. So actually, this discovery of life on Mars will open the floodgates, will open up 1,001 questions. So as a school teacher, I can ask a student a lot of questions if they discover life on Mars. So at least minimum we can get some good information from this 2 Earth year Perseverance mission. But at least to confirm it, to bring back sample from Mars successfully, 2013, another 10 years. So another 10 years you will know. But then what about the other one? You didn't post the negative question. What if they bring back all the sample from Mars and future mission from Mars come back with sample, no confirmation of life? So what will human being be? Oh, it will be another big changing in the thinking of human being. We are alone. And then back to fighting between human being and human being. Many scientists believe that no life in the universe except on Earth. But majority will say there's life, especially one. There are now more than 4,000 exoplanets discovered in the Milky Way. So basically, this Perseverance mission has a big implication in everything. Yeah. Anything else?
Okay. So I think it's almost time. So I actually have a questions for our David and Marcus. So
Yeah.
okay. So actually through this mission, actually do you have how that this mission affects you, or maybe in your future career or in your
Good
studies,
question.
or how how or any encouragement you like to give to our Malaysian young students on maybe pursuing their career in aerospace or astronomy, or any self experience you like to share through this mission, how it inspire you or whatever you think.
You know,
Marcus?
I
Okay, David.
I think one of the most inspirational moments for this mission in particular so far lah, for me is that specific picture of the Perseverance hanging from three cables over a few meters over the Martian surface. Like knowing that it's a Mini Cooper sized object suspended by rockets hanging from three cables over a few meters of the Martian surface, seeing the exhaust of the rocket affecting the surface as it creates like dust plumes on the surface. That is so amazing to me.
Yeah.
Like,
This one.
yeah, this one
Very amazing to me also.
really
Very-
amazing. It's
One
amazing
ton,
photo.
1 ton.
Like, if you imagine like someday there will be human beings on Mars, like, wow, it's very crazy to think of. Someday lah, someday.
I think for me the biggest inspiration is Ingenuity and Moxie, because Ingenuity, it will be like the first time someone actually operate like a powered flight on Mars. If it actually succeeds, there will be a lot of new possibilities for future Mars missions that involve powered flight. There can be drones that like fetch stuff for the rovers. It will make Mars exploration so much more easier for the rovers. And about Moxie, the if Moxie succeeds in turning carbon dioxide into oxygen, human exploration, human like setting up a Mars base will be so much easier, because we can literally just turn like the Mars atmosphere into oxygen for us to breathe. It will be so much easier to colonize Mars.
Lai, you also can answer one. It's a good question. Lai, you can answer that question.
I'm asking these questions only.
Oh,
And for Dr. Chong is,
You're an aerospace one.
I'm in the aerospace field, but I'm the reporter of this this session. So I'm asking this.
Short comment.
Yeah.
Now they have flown Ingenuity on, let's say if successfully flown Ingenuity on Mars, hey, the idea of powered flight on Mars works, So that means what? They create future industry for what they call this aircraft using atmosphere on Mars. Create a new industry. And now Moxie, it works. So now a lot of companies, you want to build Moxie equivalent type of thing, convert a carbon dioxide to oxygen. So they're creating new industry in the future. All right. So maybe in the future there's a new term, Martian aeronautics. But now the aeronautics is basically aeronautics in the Earth's atmosphere. So in future is Earth aeronautics law, Martian aeronautics law, Venus aeronautics law, and so on. New industry, yeah.
Yes, maybe I add on a little bit is this aerospace and astronomy, these two are very related. So it's quite fun. With more and more we can go in future, we can achieve more through. So to those who are interested to explore the space or get involved in this aerospace or aeronautics or astronautics or even astronomy, astrophysics, I think it's a good start. And we don't know how things will go on in future, but then I have a feeling that there will be a continuous demand in this aerospace in this aerospace field. So Any advice from Dr. Chong for our students or our
Now,
Malaysians?
sorry,
Yeah.
but concerning me and my age, I'm still so excited now, like a little boy about this 2 days ago, 2.5 days ago landing. So much opportunities, so many things, So in other words, for example, you need not, you may say, I come from a small country in the world that don't have aerospace or even aeroplane industry. I cannot do. No. Maybe you need expert to develop new types of sensor, which from a small country you can develop, or new type of software which is only used in space exploration. So a lot of technology is used for other purposes on Earth can be transformed and used for space exploration. And previously, there's no opportunity. Now you can develop software and whatever. So you may be a consultant developing software for a certain mission, and all other countries can use you as a consultant because you are very good in your job. So all kinds of possibility, all kinds of possibility.
Yeah, just to add on. So studying astronomy, astrophysics, astronautics or aerospace or whatever space related this industry, it's not necessary that you come out, you have to be astronomers, you need to be this professionals, aerospace engineer. You can actually involve in many other industries also, including those IT industries or even in financial industries, because it's actually what you have learned and the skills you have learned through the process of this. Maybe after a period of going through all the courses and you find your interest is not really in this, you can still go to other field, other industries, but then the process of going all through this, if you have interest in astronomy or space exploration, I would say is fun. It's extremely fun. It's exciting. Yes. So before we end this session,
One more, I add to a comment line.
yeah.
The post-landing press conference in the NASA was held in the what they call JPL auditorium. They were asked. So one of the scientists said that actually there are thousands of engineers, scientists working on this project in USA, and altogether around the world there are 35 companies around the world from 11 countries in the world taking part. So all over the world. And he also mentioned that in the 9 years, they developed this, even the curiosity, even earlier, developed curiosity and person. Many of the people in USA around the world, they joined in and they left for other job, like you said. And they can also, as a kind of a career path, doesn't mean you have to stay with this aerospace. They join this mission and then they left also. So 35 companies from an institution from 11 countries in the world, including USA, took part in this Perseverance.
Okay. So anyone want to add on any comments before we end the session? I think
Add
it's
on one final comment. I sorry, it will not happen in our lifetime, lah. I think if you are telling, hey, good idea. No, this one is, remember on Earth, what collecting people collect stamps, people collect this, collect that, and then you go to a museum, wow, this American museum showed the first Gemini spacecraft, the first moon rock, and then you go to even in Beijing, you have the new aeroplane, the new helicopter, and so on. In future, many years from now, a company will set up on the Earth. They'll go to the moon and collect all the rover, all the lander that are not working because they have technology in future. They bring those rover and lander on the moon, on Mars, around the solar system, and bring back to Earth and create a big museum. Museum of Solar System Exploration History. In future.
All right, so I think it's almost time for us to end our session. So again, we'd like to thank our audience for having patience with us. All right, and I hope you all have gained something from our discussion. And we have a lot of interesting questions, good questions throughout the discussion. And I hope we did answer your questions well and you have a satisfying answer from us. And also at the end of the session, before we end, I would also like to invite our audience, remember to like our Facebook page this one, Astronomical Society of Penang,
And
and also our YouTube channel. Subscribe our YouTube channel. Also, we have an Instagram called Astronomical Society of Penang, and go to follow us. I think we will share the QR code for all these websites, the Facebook page, YouTube, and our Instagram in the comment section shortly after these sessions end. So we welcome everyone to join us, and we hope to see you all in our future discussion. We have more and more interesting upcoming events in the future.
Right, mention the Tianwen-1 post-landing discussion. We are going to have.
Yeah, we also follow the Tianwen-1 landing. Okay, we're not sure we'll have a live discussion or a post-landing discussion, a live landing discussion or post-landing discussion, right? Depends on the landing time and depends on our availability. So once again, thank you everyone. Thank you, Dr. Chong. Thank you, David, and thank you, Marcus. All right, and thank you, our Chin Tiong, for taking care of all the technical things in this. So have a good night, everyone.
Thank you, Lai. Just one more
Enjoy.
one. Remember, Curiosity traveled 22 kilometers on the moon, So Perseverance have a long path. If you travel a lot, Perseverance will travel 22 kilometers on the moon, 1 Martian year. It's like you travel from Batu Tinggi to Bayan Lepas, or from Kepong to Dataran Merdeka. So a lot of work for this Perseverance to do, 22 kilometers. Okay,
and just a little bit update on this Hope mission and this Tianwen mission is both of them are currently orbiting Mars and is up to their expectation. They are working well. So we hope and we wish all the best for the other two missions as well. All right. So thank you, everyone. Thank you, Dr. Chong. Thank you, David. Thank you, Marcus.
Thanks, Lai. Marcus, David, and Michael.
So Chin Tiong, thank you.
Right, good night.
Thank you.
Thank you.